Looking at Module 2.1, Piggies and Pools, this is another develop an understanding task, which means we're just at the beginning and we're developing an understanding of discrete versus continuous functions. The great thing about this lesson is it gives us a chance to practice what we learned in Module 1, which is seeing a pattern and creating tables, graphs, and writing equations. So we'll start the lesson there. Each of these problems tells a story, and then you want to complete a table, a graph, and write an equation. So number 1 says, my little sister Savannah is 3 years old. She has a piggy bank that she wants to fill. She started with 5 pennies, and each day when I come home from school, she is excited when I give her 3 pennies that are left over from my lunch money. Use a table, a graph, and an equation to create a mathematical model for the number of pennies in the piggy bank each day. So this one, it says she started with 5 pennies. So that means before the sister started coming home from school at 0 days, she had 5 pennies. That's how much was in her piggy bank. And then the first day the sister came home from school, she gave her 3 pennies, and that gave her a total of 8. And then the next day, sister comes home from school, gives her 3 more pennies, and that gives her 11. Next day, sister comes home from school, gives her 3 more pennies, that gives her 14. So we have a table, then we want to make a graph for that, and then you want to write an equation. Both explicit and recursive are in the formative. So the next story, same thing, different story. Our family pool has a small pool for relaxing in the summer that holds 15,000 gallons of water. I decided to fill the pool for the summer. When I had 5 gallons of water in the pool, I decided that I didn't want to stand outside and watch the pool fill, so I had to figure out how long it would take so that I could leave, but come back to turn off the water at the right time. I checked the flow on the hose and found that it was filling of the pool at a rate of 2 gallons every minute. Use the table, graph, and an equation to create a mathematical model for the number of gallons of water in the pool at T minutes. So this one starts, it has a total, well, it started empty, right, because we're filling the pool. But she does say, this one's kind of weird. You could either start with, we don't know how many minutes it took her for 5 gallons, so you could say at 0 minutes the pool was empty, right? And then she tells us that this has a rate, which is our action, of 2 gallons every minute. So at 0 minutes there was no water. At 1 minute there was how many gallons, right? At 2 minutes there was how many gallons. So make your table, make your graph, write an equation. Notice as I'm reading, I'm highlighting this key information. Number 3 is a little bit trickier because we're talking about percents and interest. It says, I'm more sophisticated than my little sister, so I save my money in a bank account that pays me 3% interest on the money in the account at the end of each month. If I take money out before the end of the month, I don't earn any interest for the month. I started the account with $50 that I got for my birthday. That's my start value. Use a table, graph, and an equation to create a mathematical model for the amount of money that I will have after m months. So the thing about percent interest is that there's a video in the formative to help explain this better. But when you earn interest, you're earning that on top of the money that you already have. So to figure out percent interest, you get to keep 100% of the money that you already have in your account because the bank is giving you interest. And then they're going to give you an additional 3%. So the amount of money in your account next month is going to be 103% of the money that was already in there. So you always, if it's increasing in percents, you take 100, you add the new percent, and you get a total of 103%. And then to turn it into your growth factor, you're multiplying your original amount by the percent as a decimal. And so if you look down here at our percent, to turn a percent into a decimal, we move it over twice because it's out of 100. So 1.03 is our growth rate. And so I'm going to multiply 50 times 1.03 in my calculator and get my new number. And then I'm going to do the same thing here, times 1.03. That becomes my common ratio. When you look at this problem, it will look like it's linear because 3% is a very small amount of interest. So the growth will be kind of a low slope, but it will curve a little bit. So remember that just because my graph doesn't skyrocket doesn't mean that it's not geometric. Because I'm growing by using multiplication, it's going to be a curved graph. Problem number 4 is similar in that we're draining the water and there's a percent. Percents are should be a big alarm going off in your head. This time 3% is draining. So we're not adding 3% to our bank account, we're taking away 3% from our water in the pool. So when you have percents that decrease, you start with 100 just like we did before, and then you subtract the percent, and that gives you a new total, which is, in this case it's 97%. So you start with 100, you subtract the amount that it decreases, and then you have a new percent, and then you turn that into a decimal with the same strategy, either by dividing by 100 or moving the decimal. So if I start at 97%, then I move the decimal twice, and I get a common ratio of 0.97. So before I started draining the pool, it was full at 15,000 gallons. And then each time I'm multiplying that by 0.97, which is a decimal or a fraction, so it's going to decrease. And each time I'm going to multiply by 0.97. Also, since we're multiplying, it's going to be geometric. Percents are always geometric. And then we will do 5, 6, and 7 on day 2 of this lesson.